Okay, here we want to prove an equation regarding the radii of three tangent circles. All right, so let's look at this diagram here. 9L is tangent to big circle O1, O2, right, at point A and B, right? And the tiny circle squeezed, inside here is tangent to 9L also, but also tangent to both circles. Now we want to prove the radius of the smaller circle, right, has satisfies this equation here. All right, so I want to prove this. Why don't you think about it to see if you can figure out the proof, and when you're ready you can continue with the video. All right, so one interesting fact here is, let's look at the length AB. All right, so let's pay attention to the following shape here, right? So this is a circle R2, right? This is R2, right? And here this is R1. Okay, but look at this O1, O2. Look at this line here. Here's the length of this. I claim that is R1 plus R2, because the other one is the radius of O2, right? And here we want to find out what is the length of AB here, right? We want to find out what is the length of AB. So when you think about it, if you have a line parallel to AB here, this length must equal to AB, right? And this length in this triangle, this is a right triangle here. So you would have, the length of AB, okay? So if the length of AB, equal x, and here x, I would claim that is equal to, let's say, this is a point D here, right? Would equal to, Pythagorean theorem tells that that's equal to the square root of, so R1 plus R2 square minus what? Minus this segment here, right? Let's change the color here. All right, so minus this segment here. Right, so this segment here, the length here is R1 minus R2, right? Here, of course, we assume R1 is bigger, right? So this is R1 minus R2 and then square. So when you work out this actually equals, because this is going to be 4 R1 R2, right, and square root, so it's going to equal R1 R2. All right, that's okay. Now, however, we want to prove the relation here with R1 R2. Now when you look at the 9th segment here, can be divided in two parts. In other words, this 9th segment here is actually equal the AC segment here, right? And plus CB here, right? Plus, let me draw another color here. How about yellowish? This is here, right? But AC, you can use the same trick here, right? Just look at this blue shape here. In AC, here, let's magnify this, right? So for AC, let's look at this green shape here, right? This is R1, right? And here, this is R. R is smaller circle. And this length here is going to be what? R1 plus R. So you use similar logic here. You can claim that the length of AC equals the length of O, let's say E, right? and here this is going to be the difference here, right? So this part is going to be R1 minus R, right? And here is so you're going to use the same logic. You can say AC here, right? The length of AC would equal 2 square root of R1 times R, right? The steps are identical, right, to the previous logic here, right? So similarly, what you can claim is that the CB here is going to be looking at a different shape, right? So you can look at this shape here. This length is going to be R2 plus R, right? And this is R2. So your CB here, you can use the same algebra to find out that is equal to R2 times R. Of course, we know that the segment here must equal to the sum of two segment AC plus CB. So you plug in what you get. So AB's length, earlier we know that is equal to square root of R1 R2. Now it's equal to square root of R1 R plus 2 square root of R2 and R, right? So what you do is you divide all the both sides, right, by 2 square root of R1 R2. Okay, so the proof, the step is that you figured out the segment, length of whatever the shape here is equal to square root of some R, right? Either R1, R2 in different cases, right? And then you use the fact that AB length equal AC plus CB here, and then you have this equation here, right? You have this equation, and then you divide it on both sides. On here, what do you get? You get left hand side, you get 1 over R, and the right hand side you're gonna get 1 over R2 plus 1 over R1. This is exactly what we want to prove, right? This is this is okay. So that's it for the proof. So we have proved this statement here, and okay, that's it for today. Hope you enjoyed the video. Thank you.